Hey everyone, and welcome to This Explainer. I am absolutely thrilled to welcome the PyLadies Rivers cohort to week 2 of your Python programming journey. Seriously, it's so great to have you all here. We are going to dive right in today because we're moving beyond the absolute basics and starting to give our programs some real memory and honestly, some real power.
All right, quick look at today's game plan. We'll start with a welcome back to week 2, dive into variables as your data containers, break down the core data types, look at inputs and operators, troubleshoot some common beginner errors, and finally, we'll wrap up with a teaser for week 3.
So let's get into it. Section 1. Welcome to week 2, building the engine.
Just take a second and look at how far you've already come. Last week was all about getting things set up. Think back to week 1 for a minute. You installed Python, you got Visual Studio Code up and running, and you actually wrote your very first program. You literally told the computer to print "Hello World," and it listened to you. That was the spark, right? You proved that you can communicate with a machine. But as awesome as printing static text is, it's really just the tip of the iceberg.
And that brings us perfectly into week 2. We are shifting gears. We're moving from just printing out text to actually working with data. Data is basically the information that your programs are going to store, process, and spit back out. To make our programs smart, like actually useful, we need a way to hold onto that data, remember it, and change it up when we need to.
Which leads us to section 2, variables, your data containers.
Okay, so what exactly is a variable? The lecture notes use a really brilliant analogy for this. Just think of a variable as a container with a label on it. That is literally it. It's a named location used to store information so your program can easily find it and use it later on. Think about it like you're packing away stuff in your house. You'd put a label that says winter clothes on a physical box, right? Well, in Python, we're just putting a label on a piece of data. But Python does have some pretty strict ground rules for how we write those labels. Let's compare some good and bad ones. Good variable names use letters, numbers, and underscores. So things like student underscore underscore age or score 1 are totally fine. But the bad labels, they break the rules. Python will absolutely not let you start a variable name with a number, like one name. It'll also get completely confused by spaces, like typing student age with a gap, and special characters, dashes, @symbols, hashtags, entirely off limits. The golden rule you want to remember here is just to use meaningful names that actually describe the data inside your container.
All right, moving on to section 3, the core data types.
So we have our containers, but what do we actually put inside them? Python categorizes data into different types, and there are 4 main ones you really need to know. First up, strings. This is just text, and it's always enclosed in quotation marks, like the word hello. Next, we have integers, which are your whole numbers, like 25. No fractions, no decimals allowed there. If you do need a decimal, say for a price tag like 3.14, you use our third type, which is called a float. And finally, we have booleans. These are super simple logic toggles. They can only ever be true or false. Understanding these 4 types is kind of like knowing the difference between putting a liquid, a solid, or a gas into a container. They each behave in their own specific way.
Section 4, inputs and operators. Okay, first question. How do we actually get data from the real live person using our program? Well, we use the input function to collect that information. But here's the tricky part, so pay attention. When you use the input function, Python always stores that data as a string, as text. So if you ask a user for their age and they type 25, Python stores it as the text word 25, not the actual math number. Because of that, we have to use conversion functions. We use int to turn it into a whole number, float for a decimal, or str if we ever need to turn a number back into text.
Once we've got our numbers properly stored as actual numbers, we can do some math. This really shows off Python's arithmetic operators. You've got your standard stuff, addition, subtraction, multiplication, and division. But definitely keep an eye on those last 2. The percent sign is the modulus operator. Now, it does not calculate percentages. It actually gives you the remainder of a division. So 7 modulus 2 is going to give you 1. And the double asterisk, that's how Python calculates powers. So 2 power 3 is 8.
Now this is absolutely crucial. Pay super close attention to the equal sign. In regular math class, an equal sign means these 2 things have the exact same value. Well, not in Python. In Python, a single equal sign is an assignment operator. It literally means take the value on the right side and store it in the container on the left side. So age equals 25 simply means put the number 25 into the container labeled age. We also have these really handy shortcuts like plus equals, which lets you add to a variable and update its container all in one quick step. So that begs the question, if a single equal sign means store this, how do we actually ask Python if two things are equal? We use comparison operators, and specifically the double equal sign. When you type two equal signs back to back, Python actually checks the values and gives you a Boolean answer back, either true or false. We also have not equal to, which is written with an exclamation mark and an equal sign, along with your standard greater than and less than operators. These are basically how we let our programs evaluate facts.
But hey, operators aren't just for math numbers. We can totally use the plus sign on text strings too. In the programming world, this is called string concatenation. It's a big, fancy-sounding word, but all it really means is gluing text together. For example, let's say we have a container called first_name, holding the word Ada, and last_name holding Lovelace. We can combine them. By printing first_name, plus a space and quote marks, plus last_name, we join them up into one continuous string of text.
And boom, there's our output, Ada Lovelace. This is actually a really fun nod to the upcoming PyLadies Rivers AI mentor, Ada. By storing the different parts of her name separately, our code was able to combine them dynamically whenever we needed to.
All right, Section 5, Fixing Common Beginner Errors.
Listen, please hear me when I say this. Error messages are not punishments. I promise. They are just helpful clues from Python telling you exactly where it got confused. Let's look at 3 super common ones you are definitely going to encounter, starting with the syntax error. Honestly, this usually just means you made a typo. Python is incredibly literal. If you open a bracket, you absolutely must close it. If you type print, open bracket, quote, hello, quote, but leave off that closing bracket, Python just throws its hands up in the air. You fix it simply by adding that final piece of punctuation. Next up is the name error. Imagine asking a friend to hand you the blue box when there isn't a blue box in the room. They'd look at you like you were crazy, right? Well, if you tell Python to print a variable called age, but you never actually created a variable named age in the first place, it panics and gives you a name error. The fix here is super simple. Just make sure you define your variable, create your container before you try to ask Python to use it. And third, we have the type error. This happens when you mix up your data types in a way that Python just doesn't understand. Like if you try to concatenate or glue together the text string age, directly with the integer 25, Python is going to stop you right there. You can't join a text word and a math number directly. The fix? You just have to convert the integer into a string first using that str function we talked about, making them both text so they can be glued together perfectly smoothly.
Which brings us to Section 6, Summary, and our Week 3 teaser. There's a quote in your materials this week that says, "Programming is a skill. The more you practice, the better you become." And you know what? It is so incredibly true. Variables, integers, concatenation, I know it sounds like a lot, but none of this is magic. It's just vocabulary. And like learning any new language, it feels a little clunky at first, but with practice, it becomes complete second nature. Your assignments this week, like building an age calculator, are exactly how you're going to build that muscle memory. And you are going to need that muscle memory for sure, because Week 3 is where the real magic happens. Next time, we're going to be looking at decision-making with Python. We're going to take those Boolean true/false values and those comparison operators you learned today, and we'll use them to build if, elif, and else statements. You will literally be teaching your program how to make choices completely on its own. If variables are the memory and operators are the actions, just imagine what incredible things you'll build when you give your program the brain to make its own decisions. So practice those variables, get super comfortable with your data types, and I will see you all in the next explainer.